Yeah, thanks for joining. Sorry for my voice. And thanks for assigning me to the second day. Let's just start right away. That's me. We may have met before here. I've done a couple of talks, and I never thought I will ever do a talk about Windows monitoring, but well, here I am. Working for Console, you've maybe figured it out for over 20 years now, and doing monitoring there. But why we're here? A lot of our customers are using NSClient, probably all of them. And let's have a quick recap what NSClient actually is. It's the most common monitoring agent for Windows and Linux, but I don't think anybody is using NSClient for Linux, is it? No, don't think so. But it's affected the standard for Windows monitoring, or at least it was. It supports several protocols like HTTP or checkNT and NRPE. Yeah, NRPE. It has a REST API to check a lot of things, and many more. It has lots of built-in checks. I think that's what it really makes it helpful on Windows, because there's so many things already built in. It's extendable. You can add your own checks, and it's easily customizable. But well, there are a couple of problems. Like I said, all our customers are using NSClient in at least in some way. Before starting this project, I thought about 15,000 installations, but I was wrong. We're talking about 250,000 installations of the NSClient across our customers. And they're usually happy with NSClient because it does what it should do, and well, that's it. And it was a good idea to have Lego people in an NSClient talk, so to make the transition easier. So, but what's the issue actually with NSClient? The thing is, it uses quite an old SSL implementation. In fact, it can talk TLS 1.2, and the last release is, well, I looked it up. It was 2018, so it's 5 years ago now. And then we're quite unsure what happens there. So we try to reach out to Michael, and we don't really get an answer. And well, when the years go by, we have to do something about it, and nothing happened. Well, yeah, the security scanners just nagged us every year and say, we have to do something about it. Okay, yeah, we just wait for the next release, and we're still waiting. So I guess everything is fine. Yeah, but besides those issues, NSClient is actually a good solution, right? So, but well, didn't help. So we tried to go the easy way and just replace SSL and rebuild it. How hard can it be, right? So, but others tried it before, and I mean, didn't work. So we had a look for other alternatives. Want to see, well, because of course we're not the only one who are looking for alternative, and there are a lot of alternatives spreading, coming up everywhere. But let's have a look at the requirements, because having that large amount of Windows installations, we need something that basically is a drop-in replacement, and then understands the NSClient INI, and of course must work on Windows. Linux would be a plus, and it should have modern SSL, and it should more or less just simply return the same things as NSClient would do. So just same checks, same check arguments, same check result. That would be nice. So just basically just NSClient with recent TLS. And yeah, we don't want to change the Nierlein configuration. So we just want to replace the agent and everything should stay as is. And well, when we made the requirements, we said, okay, let's just add a little bit of prometheus to it, because well, if you're trying to do both things, the prometheus for metrics and Nierlein for the fault monitoring. So let's, well, if we consider a new agent, then just do both of it. So that's why we created SNClient Plus. We just swapped the S and the N and removed one plus because we had to remove a lot of craft. It's a complete rewrite in Go. So we started from scratch, and in order to make it run on all platforms, we choose Go. It's compatible with the NSClient ini. And it's dual stacked, so it uses the NSClient things and Prometheus on the other hand. So I get asked a lot, what does SNClient mean? I don't know. So it just well, basically we just flipped the first two characters, but let's ask the chatbot what he think it could mean. I don't know, security networking client. Why not? Well, AI is not that clever. My favorite is server ninja client. Yeah. So, but the actual meaning is server Nierlein client. But I'm fine with server ninja client if you want to talk it like that. So how does it look like? Basically, we have on the left side we have the old NSClient things. They are reachable with NRP and REST API. We removed check-NT, or we didn't implement it. And the Prometheus stuff is only available with HTTPS. So let's have first a look at the Nierlein stack. So to the left side, the Nierlein stack consists of checks, plugins, and external scripts, just like before. And this how it might look like. You don't have to use truck SUI. SNClient is totally unrelated, and you can use it with Isinger, Nierlein, Schinken, whatever you like. But first we have to install it, and for convenience we have made an MSI installer for Windows. But as I said, it's also available for Linux. So we have a Debian and RPM repository. But basically, it's a single Go binary. You can just put it there and start it. But of course, the MSI installs a Windows servers and such things. So it adds a little bit of convenience. And the same is for Linux. You just add the repository, install it, and you get a system D entry and everything you need to get it going. It also has some built-in checks, like most of the original checks, like check CPU, for example, drive size, memory, process, service, and so on. And you can always get the full list with the check index. And with NSClient exe run, you can run the commands if you just want to test it on the command line. So you can run any command like that, but you don't have to. Usually, you would just utilize check NSC web to request the status from the via the REST API. That's the recommended way. And well, it's really just like before. You couldn't use any. You don't have to use check NSC web. You can use other plugins designed for NSClient as well. But that's what we use. You provide the password, the URL, and what check you want to do, and then you just get the result, and it basically just looks like before. As the slide mentioned, we support NRP as well for compatibility reasons, but usually check NSC web is the recommended way, and you can grab it from that URL. Just like with NSClient, most of the things have to be enabled first, and in the default configuration, it's a little bit, well, most things are disabled for security reasons. So if you want to use them, you have to enable them, just like a check system, for example, or a disk and WMA. And it has the same settings for allowed hosts and passwords and etc. So yeah, while on it, just have a quick look at the configuration. As I said, we use the NSClient ini format, or SNClient ini, I don't care. But small differences. The SNClient ini contains all the values in the default configuration. It's not like you get an empty NSClient ini file and have to add everything by yourself. So you get the standard ini file with everything inside, and then best practice is to put your local overrides in a local file, and then you just put the things you want to change in that file, and then yeah, you always know what you have changed on this installation. And you can use the SNClient ini to look up existing configuration values. I think this is different to NSClient because according to my knowledge, NSClient did not override config values if you use them multiple times. And this is different in SNClient. So it's just read from top to bottom, and whenever a value is set, it will override the existing value. So that way you can leave the default ini file like it is and just override the things in the local file. The config inheritance is like this. So you can have default values in multiple instances. So basically it overrides them from top to bottom. The most significant or specific category defines a value, and but you don't have to. It will be overridden or set by other defaults as well. And as last we saw, you have the settings default, and there you can basically set anything, and it will be used in the other categories as well. You can use macros. That's not a new thing, but we added a couple of ones. For example, the host name or the operating system or the architecture, and that's how it's used. So you just have the setting and you just put in a macro, and then the value is replaced during reading the ini file. It's not replaced during runtime, it's once replaced during reading the ini file. But the new thing is you can use on-demand macros, so you can access values from other sections as well. So this is just an example. So we have a dummy check here defined, and it just dumps out the allowed host. There's an actual use case for that because we want to have a checking if the allowed host list is looks like we want to. For obvious reasons, those macros are replaced when reading the ini file and not during runtime, because you just could dump the password or something like that. So they are not allowed as arguments. And the third thing is they are called operators, so you can transform those macros into different forms. But there are only two right now. You can lowercase or uppercase those values, and if you need that. Then continue with filters. They just work like before with NSClient. So you have a check, you check for services, and then you have a filter, and it works like that. So basically the SNClient builds up a table of all the things it can check internally. Then it applies the filter and removes all those things it doesn't need. And at the end, the final state is calculated. So a filter always consists of an attribute, an operator, and a value, and you can combine several of them by logical operators. Well, that's the only difference is that it's always attribute, operator, value, and NSClient supports a little bit more, but we haven't done that yet. And there are tons of operators available, like list comparisons and regular expressions and such things. we added a few ones, like for example, case-insensitive regular expressions, but there's a complete list on that link. And thresholds just work the same way as filters, except they don't remove this value. It sets the corresponding state. So here we have a warning and critical threshold for the CPU, and it just compares that with the same operators. And the new thing is, if you have multiple thresholds, SNClient will try to figure out if this could be a threshold range, like it is possible in the usual monitoring plugin. So, I mean, this example doesn't make sense, but just if you have two thresholds for the same attribute, like this used, it must be bigger than 10% and less than 30%. Then SNClient tries to convert that to a threshold range, put that in the performance data, this at 10, 30, and then your performance graphing tool can add the right entry into graphing solution. In order to make this work, you have to use recent NSC Web plugins, because previously it just converted that thing to a number, and if you convert that to a number, it's just a 0. So make sure your plugins are up to date. External scripts just work mostly like before. You have to enable it in the module section first, and then you can just define batch scripts or shell scripts for Linux, PowerShell scripts, whatever you like. That's the short syntax. You just said, okay, this is my name, this is the script. It can have arguments if you allow that. Or the verbose format, where you just have a section for each check, and then you can override each setting, like allowing arguments and things like that for each check. What I saw a lot when looking at existing NSClient INIs, something like the first example. We first start a command, and this prints something and pipes that into a PowerShell, and then we try to extract the exe code. Don't do that. You don't have to do that. Just do it in NRPE style and enter the command, and it will work. In addition to that, we have added a few plugins, and the difference to the built-in checks is that they work more like the monitoring plugins. So they don't have this filter and warning threshold syntax. They have normal arguments. And right now there are, for example, of course we added check NSC Web because then we can run. We can use SNClient as proxy, for example, so we access SNClient and ask another one via the first NSClient, but we also added check HTTP, TCP and DNS check, and just the most basic ones, because we use them a lot. So you can, for example, have your agent make sure that this Windows client can access certain web pages or something like that. And we didn't reinvent the wheel. We just used the existing plugins from here and adopted them, or tried to add them here. Of course, they have to be enabled as well. So by default, you're not allowed to use them. You have to enable those built-in plugins as well. Here's an example, so you can make sure your Windows client can access certain web pages. As I already said, you can use the run command to just try certain check plugins, but usually you would use check NSC Web on your monitoring host to access the SNClient, and then run the actual command, and you can have that endlessly. So yeah, and the second example is you can use SNClient to run NSC Web to check another SNClient if you like that. And that's an actual use case. What was? Yeah. Let's talk about security, because I mean that's the main reason we are here. Go comes with its own SSL TLS implementation, so it's not. It does not use the system TLS support, and that's a great advantage, because even on older machines you get the latest SSL and TLS implementation. So, for example, if you have maybe a Red Hat 6 or old Windows installation, you always get the latest TLS support because it's included in the agent. Go itself has strong encryption and security standards, and in NSClient you could choose the ciphers by yourself. With Go you can't do that. Go decides that for you and says that's the fine ones. But another thing is you can use hash passwords. In the SNClient, in the NSClient, the password was clear text, and with SNClient you can have hashed passwords, and yeah, you don't have to use clear text passwords anymore. And another thing is the allowed host setting is used for all listeners. It's not only for NLP, it's also used for the REST API or even for the Prometheus listeners we will see later. So let's have a look at the Prometheus stack. And Prometheus works a little bit different. Usually you have exporters and they provide metrics, and we have several exporters included in the SNClient, and well, let's have a look at them. The first one is the exporter. It's a reverse proxy for other exporters. So that's common setup. So you have a node, and it has let's say a MySQL exporter, and for each application on the thing, there's an exporter, and it opens a port, and you have to request all of them. And it's a little bit cumbersome in the firewall exceptions. So it's the exporter's job to combine all those exporters and make it accessible with a single port, and you only have to open one port in the firewall, for example. And we can see an example here of reusing existing configuration variables, because the SNClient can open multiple ports, but maybe you don't want to do that. So everything which uses the HTTP port can use and share the same port. So for example, the exporter can run on the same port as the REST API for the NSClient and Nierlein things. And therefore, you can add the URL prefix to make it distinguishable. And yeah, the exporter is actually pretty simple. You just set the exporter modules folder, and then for compatibility reasons, it uses YAML format here, because it's really just the existing exporter. With one difference, it does not verify the metrics. The usual exporter verifies the metrics, but well, we found that that's mostly not even a good thing, because the format might change, and then you have to update the exporter. This one just passes through whatever it gets. It doesn't even have to be Prometheus. It's just you define a port and a URL path, and then it will be accessible with the exporter. And so we have this exporter module folder with a YAML file for each connection, and with the proxy endpoint you can access this client. It really just works like the Prometheus exporter. The second thing is something called managed exporters. And they work a little bit like the exporters, but they start the exporter by SNClient itself. So in the SNClient, you set the path to the exporter, and it will be started by SNClient itself. SNClient takes care of this exporter, make sure the memory usage is is in range, and it opens, or you make it accessible by another URL prefix. So again, it can share the same URL. So for example, we'll see an example. The SNClient comes with the Windows exporter for Prometheus included, and it's implemented as a managed exporter. So, yeah, like I said, it started by SNClient. We had a couple of memory issues with the Windows exporter in the past, so that's why the SNClient controls the memory usage and can restart this one. And it started as a separate process. It again has to be enabled in the module section, and you can then just request the Windows node, the Windows exporter metrics with Prometheus. And that's how a usual standard Windows exporter dashboard looks in Grafana then. We did the same thing with Linux. So then Linux had a node exporter for Linux is included as well, and just works the same way. You get the node exporter metrics with SNClient, and that's the standard node exporter dashboard for Grafana. And like every good tool, the SNClient itself provides Prometheus metrics as well. There are not that many so far. It's only the internal metrics like CPU and memory and so on. No specific metrics for requests, but that probably will come in the future. When talking about security, we also have to talk about updates, and the SNClient comes with a built-in updater. So it's, again, disabled by default. You can select which channel you want. For the stable channel, just checks GitHub and installs the latest package from there. You can set specific hours, so if you don't want to have automatic updates on the weekend and get notified by things that probably suddenly doesn't work anymore, you can skip, say, just Monday to Friday, and you get updates only on work days. If you don't trust GitHub, you can have your local URLs as well, and therefore those Go architecture and operating system macros are handy, because then you can just access those specific versions. And for some things like the artifacts from the daily builds, you need a GitHub token. That's why you can configure that here, but usually for normal updates you don't need them. Brought one example with me. If you want to replace NRPE for Linux, and it's easily doable with SNClient, you just enable those external scripts. You can use the NRPE server, but you can also use check NSC web, of course, and use the REST API. You set the alert house, and then you just like with NRPE, put in your scripts there, and I guess you just have to move the brackets, and then it just looks like NRPE, except it's probably a little bit faster. Yeah, talking about performance, this was one of the first questions. How is performance? Does it matter? But actually, they wanted to use SNClient as a proxy to access other SNClients. So they have one SNClient in every network, and they do all checks over that. So when it comes to performance, best practice is to use the Nierlein core with check NSC web and the mod given Go worker, but everything else works also quite well. And the reason for this is usually Nierlein executes the plugin then opens a HTTP connection to SNClient and gets the result. With the given worker, the Nierlein sends a job package to the given worker, and the given worker then sends the HTTP request to the SNClient, because it has the check NSC web also built in. So whenever the given worker notices there is a request with check NSC web, it just doesn't execute the command, it just sends the HTTP request. So there's no disk access required for the second approach. And we have 2 more minutes. In order to make the testing more easily, you can, of course, just use it like that and define commands and your services if you want to, but this doesn't scale. And well, if you have lots of services, of course, you use something like Zosh to configure your things or whatever tool you use. But for testing, I just added a small plugin to Truck, so you can put the agents in there, and it can tell you that those checks automatically. So that's just a handy way to make it testing more easily, but it's probably a good way for small setups to do it like that as well. So, coming to the end, the roadmap is definitely, we have to improve those built-in checks. There are a couple of things I don't like yet, like the plugin output can be improved, the defaults can be a little bit, can be improved. Then we will add more built-in checks because, well, it's just convenient. You have them built in and you don't have to build them on your own. Right now there's no configuration validator, so whatever you put in there, I mean, if it doesn't work, you will see it, but having a configuration validator would be a nice thing. The built-in help is not yet complete. There's on the web page, there's a complete help, but we want to have them built in as well, of course. And maybe we will add some support for open telemetry in the future. And yeah, with that, I say thank you. You can grab the slides here if you like, leave a star or a sticker, and if you have any questions.
Please, a warm applause. Any questions?
Hi, thank you for your talk. It was really good. You said one of the design goals was to have a drop-in replacement for NSClient, but in our environment, we have a customized NSClient.ini file because we had to add blah, 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 blah. So how do you actually consolidate those settings, spread different files on different servers? And I just want to say, okay, install these softwares, and I don't want to worry about it.
Mm.
How do you tackle that?
I mean, the easy way would just replace the exe file with the new exe file, and then it might work, but I don't recommend that. What we usually do is install the SNClient and then copy over the custom file along with the scripts you already use, and then uninstall the SNClient. No, we don't have that. So, but that's very specific to your company. No.
Any further questions? Okay, so again, applause, please.